going to finish up this unit by talking about 7.4, and here's the I can statement. The I can statement is I can show two triangles, and we're going to go ahead and write the word triangles here. We could put a big triangle symbol in there, but we won't. Show two triangles are similar using blank angle similarity. Well, this is going to seem a little bit funny, but we're going to use what's called angle-angle similarity. Angle-angle similarity. So that's what this particular section is about. It's about showing that triangles are congruent using angle-angle similarity. Okay, so we've got to have two angles in order to show that they're similar. So as a warm-up, let's talk about congruent and just remind ourselves of that. So congruent is the geometry word for equal. And in geometry, we use a special word because numbers can be equal, but geometric figures, it's kind of hard to say that they're exactly equal to each other. But what we mean by congruent, and when we say geometric figures are equal, or when they're congruent is the better word for it, it means the figures are exactly the same. Perfectly and exactly and in every way the same. Okay? So if we've got two figures that are exactly the same, the geometry word we use to describe those is we don't say they're equal, then we say they're congruent. Now I've got a bit of a trick question here in these examples. I've got a picture of a triangle right here and then one right next to it, and it looks like the only difference between these is how they're named. This would be triangle ABC and this is triangle XYZ. They look absolutely identical, and the question here is, are these triangles congruent? Well, the bottom line answer is this: not sure. You cannot go by the way a diagram looks. Okay, you cannot go by the way things look. In order to tell that these are congruent, we would need a lot more information. So we're not sure, and in order to be sure, we would need a bunch of information. So I'm going to show you the information that we'd need to have that would indicate from this diagram that these are congruent. So one thing I'd need to know is I'd need to know that this angle is the same as that angle. So the way we do that, like we mentioned in the last section, is we put one arc in each one of those. If this one has one arc and that one has one arc, then those two angles are congruent. I'm going to put two arcs right here, and I'm going to put two arcs right there, which means those two angles are congruent. And then this last one, I'm going to do 1, 2, 3 arcs and 1, 2, 3 arcs. Now we know that each one of the corresponding angles, if we want to say it that way, each one of these that corresponds to each other, that they're all congruent angles, but that still doesn't mean that these are congruent triangles. What we'd need to know is that they actually have congruent sides in between those congruent angles. So I'm going to put one mark right here and one mark right here. So we know for a fact that this side right here is exactly the same as this side right here. Now, when you get to more advanced math classes and they talk about geometry and proving ideas of congruence and things like that of triangles, then you'd actually find out that this is actually enough information to indicate that these two are congruent triangles. But if we're just kind of investigating and saying, are they, what information would we need, or how would it be indicated that they're congruent? We'd have maybe 2 tick marks here and 2 tick marks here and 3 tick marks here and 3 tick marks here. Okay? So once we have that information, then we could say for sure that triangle ABC is congruent to triangle XYZ. And you'll notice that I put these in exactly the same order. I kind of put them in corresponding order. So I've got that the corresponding angles are congruent to each other and the corresponding sides are congruent to each other. Now if you take a look at the next one, the triangles look kind of the same, but the questions are just the same. It says, are these triangles congruent? So same questions as over here. Well, the answer here is not sure. Now, what I've done on this one is I went ahead and confirmed what our eyes suspect, and that is that these two are exactly the same size and shape so that they're congruent. Now, from the eye, we're going to go ahead and say these are not congruent. This one is smaller and this one is bigger. And I'll tell you exactly how I made this worksheet here, or made this set of notes. I made this triangle here, and then I literally just copied that and changed the A, B, and C to X, Y, Z. to make this one, what I did is I copied ABC and then I cut it or pasted it over here, and I made it a little bit bigger. I made it a little taller in the horizontal direction, and a little longer in the X direction, a little taller in the Y direction. And then I took this one and I shrunk it down. So these are the same shape, they're just not the same size. So what we say there is we say they're similar. Now what I'd like you to take a look at and notice is that this angle is still exactly the same as that one. So I'm going to put one mark here and one mark here. Okay, I'm going to do the same thing up here. That angle is exactly the same as that one, and this angle right here is exactly the same as that angle right there. That is enough. Once we know that the angles are the same, basically this is a small copy of the big triangle, or this big triangle is a copy of the small triangle, just been stretched and made a little bit bigger. So the way we indicate that these are similar is we don't use the congruent symbol, we do this. We say triangle ABC, and we use one little squiggly line. Triangle ABC is similar to triangle XYZ. And by doing that, we know that A is exactly the same as X, B is exactly the same as Y, and C is exactly the same as Z. It's just that the size of the sides are bigger on ABC than they are on XYZ. So the angles are the same, but the size of the sides are not. Okay? So similar figures, let's talk about those for just a second. Similar figures have the same shape, but not the same size. So they have exactly the same shape, and that's why we indicated on the diagram up here that the angles were the same. So the angles maintain their size. It's just that the size of the sides gets stretched or shrunk to make it either bigger or smaller. So similar figures have the same shape but not the same size. So the angle measures are the same as they were before, but we either got bigger or smaller depending on what happened to that particular triangle. Now if they were exactly the same size and shape, then they wouldn't be similar anymore. The best name for that would be, they would be congruent. Okay? So congruent means they are exactly the same. Similar just means they're the same shape, but they're not the same size. Okay? So let's talk about this angle-angle similarity theorem. And when we say angle-angle similarity theorem, a lot of times we'll just say angle-angle similarity. We just use the two A's. A would represent an angle. If there were an S in there, it would represent side. So angle-angle similarity. Similarity. Okay? All right, so here's what angle-angle similarity says. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. That's all we need to know. All we need to know is that two angles of one triangle are congruent to two angles of another triangle, and that's it. We know that they have to be similar because they have to be the same size, but not necessarily the same shape. So the question here is, why don't we need to know all three angles to tell if they're similar or not? Why isn't it angle, angle, angle similarity? Why don't we have to check and make sure that all three of these angles are congruent to all three of those angles? Well, if you stop and think about it, if we know that these two are congruent, A and B are congruent to X and Y. In fact, let me change colors here, and I'm going to write down some measurements. Let's say that this one is 40 and this one is 60. So if this is 40 and this is 60, this would be 40 and this would also be 60. Now, why don't we have to check the last one? Well, if you stop and think about it, these two add up to be 100. So what does this one over here has to be? It's got to be 80. Okay, so if we do the same thing over here, if these two add up to 100 and we do a little subtraction problem based on the triangle sum theorem, this one's got to be 80 right here. So here's what we're going to say. The reason we don't have to check all three of them, the reason it's okay to have just angle-angle similarity, is we're going to say this: if we know two angles of a triangle, comma, then we automatically know the third one. Automatically know the third. the third angle. Okay, so if we know two angles of a triangle, then we automatically know the third one based on this idea right here. Whatever these add up to, in this case 100, it would have to be the same as what these add up to, because those would be the two angles that we know are congruent. So that third angle automatically has to be the same. So that's the idea behind angle-angle similarity. So remember, similarity means they're the same shape, they're just not the same size. So let's take a look here. It says if there are two triangles that are similar, write the similarity statement. Otherwise, write no similarity. So let's take a look. Again, the cool thing about geometry is using a little bit of information to make some pretty cool conclusions. So let's see, I've got an arc here, and I'm going to blow this up so we can see what's going on just a little bit better. Okay, so I've got an arc in angle D, and I've got an arc in angle P. So angle D is congruent to angle P. And then over here I've got that these two are 65, so that would mean that angle K is congruent to angle R. So if those two are congruent, then I have angle-angle similarity. So I'm just going to write angle-angle similarity. So here's what I want to work on now. I want to work on writing down this similarity statement, because it does have to be written in the right order. And I want to point this out. This is actually an error. This is not a similarity symbol. This is the approximately equal to symbol. So let me go ahead and cross that out. Let me get rid of that. That's the proper way to write it. Just one of those squigglies. Okay, so that will work right there. Okay, so we want to write down a similarity statement. So we're going to need a triangle right here. So we're going to say triangle DJK. Now the reason they wrote one of these down for us is if they wrote down DJK, we need to match that order when we're writing down the other letters over here. So if they said DJK is similar to this other one right here, let's match it up. D is this one right here with P. J is this one right here with Z, and K would match up with the R. So we want to make sure that we're going around the triangle in the same order. So DJK would match up with PZR, so triangle PZR. And you might not think that that's a big deal, but it is a big deal, because what we're saying is that angle D is the same size, it's the congruent with angle P. So take a look, those two match up. We're saying that J is the same as Z. J would be the same as Z, and it would be using the triangle sum theorem, and that K is the same as R. So K and R match up. So we just need to make sure that we put those down in the right order. So let's take a look at this next one. So let's see if we've got any information. So it says triangle NOP. So NOP. So this one right here. Can we say anything about these two triangles right here? Well, they look pretty good. I mean, this looks a little bit bigger than that one right there, but they kind of look like they would be the same. I mean, maybe I could just flip this over and they would line up or something like that. But here's the deal. The only information that I can summarize from this particular diagram is this, that those two would be congruent because they're vertical angles. I don't know that these lines are parallel or anything like that, so I couldn't say that this angle is congruent to this angle right here because they're alternate interior or something. So on this problem, we actually say there is no similarity. No similarity on that one right there, and we'll move on to the next one. Now, unlike this diagram, the next one on C, it looks exactly the same. In fact, the letters are the same and all that sort of stuff, but we have this extra little piece of information. We know something about those two angles right there. So we automatically know that angle M is congruent to angle P, and using that same idea of vertical angles, and I'm going to name it this way, angle ONP, so angle ONP is congruent to, if I went from O to N to P, I'm going to go from no arcs to two arcs to one arc, so that would be QNM. So angle QNM. Now, you don't necessarily need to write this over here, but it is a good idea to be able to understand and write the notation. We now can say that, look, we've got two angles that are similar, so I'm going to say angle-angle similarity, and let's write this down. Triangle NOP, NOP. So we're going to go from two arcs to no arcs to one arc. So on the other one, we need to go from two arcs to no arcs to one arc. So that's going to be triangle NQ, that's the no arcs, and then we finish off with the one arc, that would be N, or M. So NQM. All right, let's slide down here and take a look at a couple more. Once you get the hang of these really do go pretty quickly. Let's see, we've got a 42-degree angle here, and we've got a 42-degree angle here. So I'm in good shape there. I know that those are congruent to each other. But do we have any other information about these other angles here? I don't see any. So on this one, we're going to write no similarity. Circle that, and we are done. We'll move on to the next one. Now, there's not a lot of information given here in this diagram except for these two angles, or sorry, these two arrows on these lines right here. So what that means is these two lines are parallel. Now, if those are parallel, we actually have a huge amount of information. Now, these are overlapping triangles, so I'm going to write the word overlapping. Whoops. Overlapping. I think I need two P's in there, so overlapping. Okay, those are overlapping triangles. Now, little hint, when you have overlapping triangles, do yourself a favor and draw a big triangle out here. So I'm going to draw this triangle out here. This is going to be A over to C and then to B. And then the smaller triangle looks like this. It's from D to B, oops, D to E to B down here. So I've made this big triangle right here, drawn it out here, and then made this small triangle right there. Now, you'll notice that B is used in each one, so I'm going to go ahead and put an arc right there. And then I know, because these are parallel lines, let's take this angle right here. This one would be in exactly the same spot as that one right there. So those two would be corresponding angles, so they would be congruent. So what that means is those two angles are congruent. Now, for me, I think this is enough information. If you want to write down that angle B is congruent to angle B and angle C is congruent to angle E, that would be totally fine. Let's just make sure that we write these down correctly. So I'm going to use triangle ABC. So if I go ABC, I'm going from no arcs to one arcs to two arcs. So on this one, I need to go from no arcs to one arcs to two arcs. So that's going to be triangle DBE. Okay, again, it almost takes more time to talk about these than it does to actually solve them. Let's take a look at F. Let's see, I've got 92, so I know those are the same. This one is 47. I'm not quite sure, so I'm going to grab my calculator really quickly, and I'm going to check and see what this other one would be here. So I pulled up the calculator and did a little subtraction problem. There's 180 degrees in triangle ABC, and I subtracted 92 for this angle. I subtracted 47 for this one, so it means the last one has to be 41. So if that's 41, then those two match up. So I need to write a similarity statement, and you'll notice that there's not space, or they didn't write a space for one. So we're going to do this. We're going to do triangle ABC is similar to triangle, let's see, if we do ABC, then this has got to be DEF. So triangle DEF. So it works out that they're both in alphabetical order. That's kind of nice. Okay, let's take a look at this next one here. We've got one arc here, and we've got one arc there, and we've got 40 here, and we've got 40 there. We don't even need to know what this one is. We don't need to figure out what this last one is, angle C and angle F. We have those two angles right here, so let me highlight them, 40 and 40, and we've got A and D. Those match up, so we automatically have angle-angle similarity, so I'm going to say triangle ABC. So I'm going from one arc to 40 to no arc, so I'm going to go from one arc to 40 to no arc. So that's going to be similar to triangle. Make that look just a little bit better. Triangle, remember, let's see, arc to 40, so arc to 40 to none, so DEF. So it turns out that that one also is in alphabetical order. And then let's take a look at this last one. If this is 44, I can go ahead and mark those as being congruent. Do I know anything else on this diagram that would show me some that are congruent? We do. These are vertical angles, and it's amazing how many times vertical angles come up. So let's see. I'm going to write this one over here first. So I'm going to write triangle BCF. So no arcs to 1 to 2, and then I'm going to write the congruent symbol. So no to 1 to 2, so no to 1 to 2. So that's going to be H to G to F. H, G, F. All right. So there's our similarity statement. Okay, now we're going to go ahead and we're going to take a look at some problems from the assignment. So I'm going to flip over and we're going to look at 1, 2, 3, and 8. So on the assignment, let's take a quick look here. It says use the two triangles to the right to answer questions number 1 and 2. So if we look over here, it says, are these two triangles similar? And if so, how do you know? So let's take a look here. We've got a right angle right here. We've got 55 degrees here. I don't know what this one is right here, but let's just check and see. If I do 180 minus 90, that would be 90. And if I subtract another 35, that would be 55 degrees. So this is going to be 55 degrees. So how do we know that these are congruent? So we're going to say yes. Okay, and how do we know? Angle, angle, similarity. Okay, angle, angle, similarity. Similarity. All right. Okay. How are congruent triangles and similar triangles the same, and how are they different? Well, let's stop and think about that. If they're congruent, they're exactly the same size. They have the same angles and they have the same sides. If they're similar, then they only have to be the same shape, which means the angles have to be the same size. We can make the sides as big or as small as we want as long as it's all proportional and stuff like that. So how are they the same and how are they different? They're the same because the angles must be congruent, okay? And they're different because the sides can be bigger or smaller. Okay, so the fact that the angles are congruent, that makes sure that they're the same shape, but if the sides are bigger or smaller, then that's going to change the size of the triangle. Okay, so let's take a look at number 3. It says state if the two triangles are similar or not. If they are similar, complete the similarity statement. Okay, so let's take a look through here. We've got a 71 and 72, not quite. 37 and 36, not quite. I've got a feeling that this is not going to work, but let's just double check here. 180 minus 71 minus 37. Let's just see if we can get anything to match up. I don't think we can. So I grabbed the calculator and threw these in. 180 minus 71 minus 37, I got 72. So this one right here is 72. Now what that means is we can match those up, but we certainly can't match up any of the other ones. So on this one there is no similarity. Okay, and then let's slide down here. Let's take a look at number 8. Number 8 is over here on the other side, and this is another example of overlapping triangles. If you've got overlapping triangles, do yourself a favor. Let's draw the big one. So I'm going to draw the big one right here, and then I'm going to draw the small one down below it. So this is D, C, and F. And the small one is E, G, and F. Okay, now let's see. Angle F, it looks like, is 65. So this is 65 here and this is 65 there. So they've both got that one in common. And then let's check and see what we've got here. Angle C is 80 degrees. Okay, so that's 80 degrees. We got that one taken care of. Let's see. Can we tell anything about these guys right here? Well, let's check. If this is 140 degrees, there'd be 180 degrees altogether. If 140 are used right here, that leaves 40 right there. So let's check one last thing. I've got the 65 and the 65. If I can figure out what this angle right here is, then I can tell if I can match those up. So let's grab the calculator and type that in. So I grabbed the calculator, I typed in 180 minus 65 minus 80. So 180 minus that 65 and minus that 80. That leaves me with 35 degrees for this one over here. Okay, so there's no way that that's going to work out. We've got a 65 which matches up, and then a 35. It doesn't match with the 40. This last one's definitely not going to match up. So we're going to write no similarity on that one, and we're all set to go. All right, good practice. We'll do a day or so on this, and then we'll get ourselves ready for the test. Good luck on the assignment.